name's Les. I work for, I think some of you know me. I work from home for Mozilla, and I'm going to talk about Firefox OS tonight. Who am I? In case you don't know me, it's my best picture I have right now. And I kind of try to use file system to describe myself. I'm kind of a web and computer scientist. I write a bit. I brew beer, I roast coffee, and I work for Mozilla. And just to repeat the title slide, what is Firefox OS? Firefox OS is Mozilla's open source operating system for the open web. So that's a whole lot of opens. But we use that. So you may or may not have heard of something called boot to gecko, and what that is that's my Unix joke. If you ever wanted to like just boot straight into Emacs and just use that for your OS, that's what we want to do with the web. So we built a tiny Linux distro that all it does is it boots up and it loads Firefox. Well, it boots into Gecko, which is the guts of Firefox. But it turns out that there's more to an OS than just the browser. So I've got these are the three main parts of Firefox OS. There's the aforementioned Linux distro, which is named Gonk. I don't know why it's named Gonk. I've been trying to figure that out for like the last 2 years. I don't know where that name came from. But that's the Linux kernel and just enough processes to interface with the hardware. And there's Gecko, which is basically like a Chromeless Firefox. So it's the web rendering engine, it's HTML, CSS, and JavaScript. And then on top of that is a thing called Gaia, which is basically just a big web page. It's a web application that kind of is an analog to a window manager. It's the thing that does like the status bar at the top, does all that. And no one can read this, but this is an architecture diagram of Firefox OS, and I'll zoom into each of these parts real quick. So the first thing I mentioned is Gonk. Like I said, it's a very small Linux distro. The interesting thing about it is it borrows from the Android open source project. And that's very cool because Google made that all open source. So we kind of had a kickstart where we could take their underpinning of Linux, and that lets us kind of piggyback on some of the same manufacturer drivers for mobile hardware and things like that. And it lets us use a lot of the same low-level dev tools they have. Like there's Android dev kit comes with stuff to talk to a phone or USB. You can get logging output from your programs, all that kind of stuff. So we can reuse all that. And it also means we run on very similar hardware as Android. In fact, if you know what you're doing, if you're the kind of person that installs CyanogenMod, if you're the kind of person who compiles CyanogenMod, you could probably shoehorn Firefox OS onto the same phone. But we don't run Android apps. It pretty much like stops just before the level where you start up Java and Delphi and all that. And then what we do instead, okay, and this is the zoomed in part of the diagram that you may or may not be able to read now. And like I said, down there's the Linux kernel, there's the OEM drivers that talks to things like all the buttons and lights and the radios and the phone. And then we use a lot of Android and other open source drivers to do things like interface with the GPU in a phone, Bluetooth, accelerometer, GPS, and all that. And so this is where this is the glue between the actual hardware and Gecko.
What hardware drivers are you using? Which version of you're running?
I'm not sure exactly which version. I know the driver situation is weird because this is kind of where like the Mozilla open source thing and the carrier manufacturer closed source thing collide. Because almost all the drivers are secret. Which sucks. But this is kind of where we make our compromises with that. So then the next layer is Gecko. Once we've got our Linux up and running, it's got the proprietary drivers. We cover all that over with some abstraction layers, and then Gecko talks to Gonk through hardware abstraction layers. So there's some processes that run to manage Wi-Fi and Bluetooth and all that stuff. And Gecko is the Firefox core. And this is basically the entire programmable guts of Firefox OS. interesting thing is we do two things. We have, and so this is the zoom in of that architecture diagram. We do all the HTML5 APIs, which if you're familiar with them at all, they give you, they're kind of the new stuff. They give you better graphics, give you 3D, give you audio, video. And then at Mozilla, we've started building and developing new APIs that talk to common kinds of mobile hardware. And the interesting thing about these APIs is that we build them first, we get them to a point where they look like they're practical, and then we propose them as standards. So the thing we want to do with all these kind of green things in the middle there is we invite other vendors to make them. So I think for example, Samsung is working on an OS called Tyson, and one of the things they're doing is they're looking at our work on this and making their own implementations. So the goal would be at some point, if it runs on Firefox OS, it'll run on someone else's OS that implements these APIs. So this is the first thing I can actually show with like a screenshot of, is this is where graphics actually start to get drawn. And this is Gaia. Once you've got the Linux layer running, you've got Gecko running, Gaia is the first thing that boots up. And like I said, Gaia is basically just a web page, but that means quite a lot these days. What Gaia can render is, it does the status bar, its home screen, it can manage your apps, so it lets you launch them. If you hold down the home button, you'll get a app switcher where it can flip through and kill apps. And it also it's also where we maintain kind of the core built-in set of apps. So this is kind of like if you ever did a CyanogenMod mod on an Android phone, you have to get this G-Apps bundle, which has all the Google apps. Well, we've got that, but it's in Gaia. So this is your camera phone, SMS, all that. And then this is the very top of that diagram I started with, which basically just shows like this is where all of our apps infrastructure is. Oh yeah, I forgot about the slide. So this is a fun fact, if everyone doesn't know it. Firefox is named for the red panda. Yeah, that's the weird part.
What's the great? No. Where do they live?
There's a Wikipedia page. If my Wi-Fi works. They live in the eastern Himalayas and southwestern China.
What's more like a raccoon?
Fine, look at that. It's a combination of a raccoon, a fox, and a panda.
It's not to be confused with the red fox.
And I got a video where this screenshot came from. They're really cute.
Throwback to the 70s there.
So where I left off was the very top of that diagram, this apps. And so this is what Gaia launches. Interesting thing is that, like I've been saying, they're just web pages, but web pages, this is probably going to be a mistake, but web pages can do a lot these days. So this is a web page. It's using my GPU of my laptop. It's running JavaScript. This is something called WebGL. And so this is all hardware accelerated, it's driven by JavaScript, like I said. And this is some of the HTML5 APIs that we support just on the web now. And like you can see, this is not Firefox OS, this is just Firefox. But Firefox OS is based on Firefox, so everything that drives this is available on one of these things too. And this is a Firefox OS phone. I'll let you guys play with it. Actually, I got two of them. Let's see what they look like. Mentioned those. So like I said, there's HTML5, which is already a standard. It's been started outside of Mozilla. The Mozilla part that we're really trying to drive is we're looking at the gaps in HTML5 and saying, hey, HTML5 doesn't have an API for the vibration loader, it doesn't have an API for Bluetooth, or it doesn't have an API for various other things that are on modern, not desktop hardware, so tablets and all that kind of stuff. And our main thrust of that, like I said, is to get these this is kind of the contentious thing about Firefox OS is that web is the native on the Firefox OS device. There's no special trapdoor to like compile a binary to get it running. It's basically the only processes that run natively are the hardware abstraction layer and the Gecko engine itself. And our idea behind that is that the web at this point is pretty much write once with a lot of conditionals, and it runs most places. Which means if you get your web app to work on a big screen, and you get it to work on a little screen, and you can handle touch and things like that, it'll work on a Firefox OS phone. And then we can give you special powers with these new APIs, where like you can have a web app that once it detects it's got access to some of these APIs, can do things like talk to a Bluetooth, GPS, and things like that. And what's been exciting lately is JavaScript's gotten pretty fast. We have this thing called ASM.js that if you really need compiled code, you can compile in JavaScript, which sounds crazy, but it works a lot better than even we expected. And this is my next mistake. This is a full-on 3D game that they took the C++ and ran it through this scripted compiler, and it generated JavaScript that talks to the new 3D APIs, and it runs on this thing at like 40 frames per second. Yeah, like this isn't the video, this is actually like on my GPU right now. And I can like navigate around. Yeah, make it do it. So yeah, that didn't crash my machine. The other thing that's nice is I'm running this on a Linux laptop, so that's another really nice thing, is all this stuff is cross-platform, cross-OS. Yep, it's pretty much like all of this is in Firefox, and again, this relates to Firefox OS, in that this is in the core, and the core is in the devices, so pretty much everything I can demonstrate on a desktop works on one of these. Maybe not these, exactly. And so that, like I said, that even surprised us at Mozilla, because it took ASM.js was an experiment that like one engineer did in I think a month. It basically just made a well-trod, optimized path in a JavaScript interpreter, and from that he extracted like a lockdown profile subset of JavaScript that optimized for high performance. And they talked to Epic Games about Unreal Engine, and they said, okay, well, why not? Let's try it. 4 days later, it actually worked in the browser. So, and the reason why I mentioned that I'm surprised is because we haven't even really begun to try to squeeze the performance out of it. So there's a whole lot of headroom to make this stuff really good. So, I'm a broken record on a lot of these things, but Firefox OS apps are just web pages. That means you can use whatever JavaScript framework you want. You don't have to switch to a different language if you're already making web stuff. The main thing is that you just need to adapt your site to work with various sizes of displays. And you need to make it work with various kinds of input schemes. So you might have a mouse and keyboard, you might not, you might have a touch screen, you might have multi-touch. And if you have access to the web APIs, you may have an accelerometer, you may not. So it's a lot of kind of embracing the chaos of devices that you may be able to get your app to run on. And that's kind of the in opposition to the silo of, say, like Apple's universe, because Apple is able to say, we only have these, I don't know, like 3 or a dozen devices, so you only have to worry about these 3 cases, whereas in this world, you need to worry about a lot more little variables. But we think that's actually really a good thing, because it allows experimentation on the market, it allows lots of different places.
So is the market for this then cell phones? Is
that where this is going, or, and tablets and whatever's coming?
It's pretty much whatever we can get to run on. So at first, it's cell phones, like this one is one of the first developer devices to come out. It's a little tiny, basically Android device. Foxconn, the people that make the stuff for Apple, have been playing around with Firefox OS on tablets. We've got a few people who were playing around with it at Mozilla just for the heck of it, getting like a laptop to boot straight into it. And I think there was a Nokia engineer who got it to work on a Raspberry Pi. So that was pretty cool, because he put Firefox OS in that, put it on TV, and turn it into like a nice web-based info display. So I think eventually we're following a similar path of like, say, Chrome OS. Like we're going devices first, and eventually we'll probably get it on something like a laptop or tablet. So yeah, basically whatever we can get to run on.
So your big competition would be, obviously iOS.
Yep.
Android.
Chrome OS?
Yeah, I'd say Chrome OS, like, we're, well, pretty much competing with everybody at this point.
But you think,
Chrome OS
you
is-
think you think Chrome OS would be the competitor, or obviously Android would?
Yeah.
I think Chrome OS more as the laptop thin client.
Yeah, we're closest to Chrome OS in terms of what we're doing. Yep.
You mentioned Chrome OS, but Chrome OS needs the web to run, doesn't it?
So that's an interesting thing. I didn't mention that. Oh yeah, I missed it on this slide. The important thing, because this is actually a frequently asked question, this is one of the new HTML5 APIs. It's offline mode. And what's really cool about that, because the first question it asks, when we talk about we're going to do a web-based OS, is, well, you need the web, right? You need the web all the time. Well, the new HTML5 stuff has some interesting things for caching. So when I load a web app, all the HTML files, JavaScript, CSS, images, everything get cached locally. And then there are APIs in HTML5 to where your app can detect whether the network is available or not. So what can happen is if you have like a calculator app that never needs internet access really, once you load it the first time, it never touches the web again. If you have something like, say, I don't know, a word processor that saves to the cloud, your word processor can detect that the network is down and save to a local storage option. And when the network comes back, it can sync. So that's one of the really interesting things about this new web stuff is it's really savvy about not having 24/7 connectivity. And it's turning out to actually work pretty well, because some of the first places I'll mention later that we've got phones deployed are places that have unreliable networks. And sometimes the apps don't even get loaded until they're at a PC with a USB cable.
And so you then, as a developer, you designate which pages can be cached, and, or is that part of your application?
Yeah, so there's, it's called application cache, and it's part of the HTML5 standard. You can give it a manifest of like, these are all the files that belong to my web app. You can tell it, you can even do things like when offline, use these alternatives. So you can download a whole bunch of application code and swap in certain libraries that handle things specifically when you're offline. And the other thing that's kind of neat about this application cache scheme in HTML5 is when you install an app on, say, Android or iOS, you download the whole app package. So like, I don't know, if it's like 1.5 MB, you download the whole 1.5 MB next time you upload or update. With the HTML5 stuff, if you change just one image in your app, it can granularly download just that one resource. So we can both cache and tell it, like when you release a new version, only these things changed, so only bother to download like this 15K worth of stuff. Okay, so my next thing, I said that they're just web apps, but that also gets us in trouble because they're also strange, because they're on a mobile device, so we have to make some tooling. So one of the things we did is a Firefox OS simulator that actually installs as an add-on in Firefox. And this will actually run what's neat about this thing that you install as an add-on is you can push apps into that from your hard drive, so you can actually like do your build of your app and push it into there. And if you have a USB cable, this also serves to push apps to a device, so this kind of turns into your, it helps make Firefox a part of your whole IDE development environment. But the next thing we're doing is we're also providing some apps. Like this is an app that does pretty much everything the phone can do right now. So it gives you the sample code of like, this is how you take pictures, they send an SMS message, this is how you dial the phone. Okay, it's well commented, it tells you how the parameters work. And you don't have to use our style, but Firefox OS definitely has a style for apps. And if you're building one from scratch just for Firefox OS, we make available all the components and styles we use for our apps. So we use that starter point. Or if you're adapting an existing app, you can pull these things in as like what you use when you find yourself on Firefox OS. And then the next part, once you've got an app, is publishing it. And this is another spot where we're trying to be the Apple's App Store, they control it totally. It's the only one you can use on their devices, and they approve everything that goes on. Google's App Store, Google Play, is more open. They control the App Store, but I think they don't really exercise a whole lot of editorial control, so it's pretty easy to push an app in and get it to show. What we've been kind of thinking is that app stores are kind of the new search engines. They're kind of like Yahoo circa 95. They're like these directories where you can find things. It used to be web pages, now they're apps. But the idea is you have to submit your app to the thing. But what we wanted to do was to turn it inside out. So we do have a marketplace. We call it Firefox Marketplace. It's marketplace.firefox.com. But Firefox Marketplace is just one open web app store. And the way it works is that we've got a spec for a manifest for an open web app. And we've got some JavaScript APIs to install open apps. And those are in the browser. Those aren't in the store, they're not embedded in Firefox OS, they're just a standard that we're putting out there. And so what that means is that even though we have a marketplace, you can too. And even if marketplace just means you have a page advertising your apps with installment. And just to kind of show some sample code, this is what I mean by JSON manifest. It's a simple data structure, it says like the version of your app, what the name of the app is, a description, just icon installment. And this lives at a URL. So wherever your site is, say it's like myapp.example.com/manifest.icon. And so when you submit to a marketplace, this resource is what the marketplace uses to build like your listing. It's also, like say you want to build a marketplace, and like I said, even if the marketplace is just a one-page app for your app, this is the code that you wire to your installer. Or something like that. It's like about a dozen lines of code. There's a API in the browser. It's prefixed with Moz because we're still experimenting with it, but eventually we want this to be what a marketplace developer calls when a user wants to install an app. And the nice thing about this is that we don't control anything but the API standard. That's just a standard. So if you want to publish your app anywhere, you can. If you want to create a store anywhere, you can. And then, by the way, we'll have the one that's by default on the phone. You can change the default. And then putting these two things together, when a user clicks a button, they'll get a dialogue like that asking, are you sure you want to install this app? And I've been talking about, kind of drifted away from Firefox OS, and I'm drifting farther now because the idea behind all this is that these open web apps can run on Firefox OS or desktop or even Android. And thing that I did here just last night, I installed this app, and it showed up in my applications folder as a proper app separate from the browser. The other thing I did last night was I installed it on Firefox OS, Android, Linux, and OS 10. And each of these are basically just a Chromeless Firefox surrounding a web app. And it's the same, from the same URL, different OSs. I also got on Windows, but I didn't want to shrink everything down, just to show Windows. And again, all of this is powered by the same JavaScript. Like on Android, the way I installed it on Android is I opened up Firefox from Android, visited the marketplace, hit install, and it showed up on my home screen. And on Linux, I visited it in Firefox, and install showed up immediately. So this is the tail end of things. The interesting thing about all this is that it's a lot of kind of like theoretical stuff that we're experimenting with. But we have phones out there, right? Like this came out, and I think this came out in February. This is the Firefox OS Developer Preview phone. It's not super high powered, but we're aiming this initially at some kind of like developing markets. But it's got the specs of like, I don't know, an Android phone from say 3 years ago, which is kind of what we're aiming at for the efficiency of things, is we want to be able to run very well on this really cheap hardware. And like this was our first developer phone that we just kind of used internally, and I think this was literally like a $50 Android phone from a bin in Turkey. So we all those developers got sent like a rock bottom cheap phone. But in July, this phone came out. A limited, this like orange limited edition thing was sold direct to consumers for like $80 on the eBay store. And you could get a SIM card from T-Mobile and make it work. It also just got released by Telefonica in Spain and Latin America. This phone is the Alcatel One Touch Fire. I haven't actually held this one yet, but this is also distributed by Telefonica and Deutsche Telekom in Poland. It's kind of like one of the first markets, and they're planning to spread out from there after that launch. And so this stuff is really interesting for Mozilla because these guys don't play with open source very well. They want to lock the whole thing down. They want to have everything be proprietary. So this is one of the places where we're kind of like we're figuring out the strategy here and giving them control yet retaining our openness on top of it. And so we're sorting through things like who has open bootloaders and how can developers use these phones and how often can we update them. Because one of the things, like I mentioned earlier, Firefox OS is split into those 3 layers, Gunk, Gecko, and Gaia. And one of the things we're hoping to do with that is to update each of those layers separately. So the Linux layer may not change as fast as, say, the Gecko layer, and that may not change as fast as the Gaia layer. So this is actually a thing that like Google's trying to do with Android right now. They're moving a lot of their updates into apps because that's been the market fragmentation where we've got phones with Android 3 still on them and Android 2 and Android 4. And so they've been moving to a model where they just update the top level apps. And so that's one of the things that we're trying to go to right away. So the carriers can do what they want with the hardware, they can do what they want with the drivers, they can do what they want with Gunk to a certain point. And then some of our marketing guidelines, or our trademark guidelines and things like that, put us in the contracts where we get power to update the top end. So they let us push Gaia out to as many phones as possible.
Question, before you change the slide, how much restriction or how much openness is there, say, between Telefonica and Deutsche Telekom on, say, the Bluetooth driver for that phone?
Next to none.